Hey everyone. So I found a copy of Code This Game. It's by Meg Ray with some really playful art by illustrator Keith Zhu. And I had picked this up a few years ago and tried to convince the kids to walk through it with me, but they weren't quite enthused. So I figure it might make a good video or series of videos if we walk through it together and potentially come up with a game at the end. So why don't we do just that? I'm going to put the book in front of a camera. We will be able to step through it together and have another screen where we can try out some of the code. So without further ado, I'll just put this down on the desk and then we will go through it together. So here we have the book, and I guess we will open up to the introduction. Let's see. So there's two parts. Part 1, the introduction, and Part 2, Code This Game. So let's see what the introduction is about. Oh, there's another part here. Part 3. Break this game. Oh yes, that was promised on the cover. Was it promised by one of the creatures? Or the characters? No. I think this is the name of the game that we'll be creating and then potentially breaking. Attack of the Vampire Pizzas. That sounds like fun. Alright. So we have part 3, break this game, and then a whole bunch of appendices, and then a bunch of characters are going to appear through here and give us little tips and jokes. Alright, let's see what we got. So a lot of this intro, I think, is going to give us kind of how to use the book. And I'm coming at this as an experienced developer and programmer, but I want to put this in a form that that you might be able to follow along if you're brand new, no matter what your age. So let's step through this a little bit. What to do with this book. Make your game. Follow the tutorial to build a game called Attack of the Vampire Pizzas. This is a tower defense style game. In tower defense games, you protect someone, or something rather, from enemies by placing defenses. In Attack of the Vampire Pizzas, our game, you will use pizza toppings and tools to protect your delivery boxes from oncoming vampire pizzas. You will learn the basics of programming, aka coding, in Python, and that'll be our programming language as you create this game. Okay, and then, here's the description of the breaking of the game. Why would we want you to break the game you just made? To make it your own. You need to break this game to be able to play with it and make something new. But don't worry, you'll save a copy of the game before you break it. All right, so we're going to keep an eye out for a few different kinds of sections here. It says keep an eye out for power up. Check out these quick tips to make things easier and get your code right. We're going to look out for new words so we know what's going on. These are your guide to the language of computer science, which is important to be familiar with if we're going to be using computers. You'll be fluent in no time. And then we're going to level up. Keep track of your progress and successes as you master new coding skills. All right, so this is how it's going to cue us in when we are doing one of two things, either planning and then building and testing, or actually initiating a build when we're ready to test. I think this little hedgehog has a name. I could have sworn further back, and she's right on the cover page, or the title page, so I like this little guy too. Hello, world. There. I knew she had a name. She says, "Hi, I'm Meg. I'm here to develop your. I'm here to help you develop your new coding skills. Look for me to cheer you on and give you the inside scoop on programming." So we got a helper, a cheerleader, and an insider. We're well equipped to keep going. Okay, so anytime we see a type this, we're going to type some new code into our program, and anything marked with this hash is just a comment, so that's actually not, that'll be ignored in our code. You do not need to type the comments into your program, and I can tell you, as someone with many years of experience, I would beg people to type more comments into their code. So we'll see what that is. Maybe we'll put our own fun comments. Take a closer look. Okay, so it's got this. This section looks at code in detail to help you try to understand what on earth is going on. And once it's your turn, the your turn section asks you to figure something out on your own. Look for code comments marked with hash to do. And as you practice, the directions in this section become less detailed, so we don't get like told that, you know, these are the correct order of steps or anything. We just got to make up our own steps, and if they work, then they are good. Here's some of the vocabulary they were talking about. Refactor. Sections ask you to go back and change code that you've already written. You have to be willing to erase and refactor or restart or recreate some of your code if you're going to improve on it. And you might have to try a few different things before you're successful. That's a normal part of programming. Kind of like if you ever went to the beach and built a sandcastle, you got to be willing to build that sandcastle again when the wave comes in. All right, here's Grace's Corner. Admiral Grace Hopper was a famous computer scientist. She invented early computing tools and paved the way for programming languages that were closer to English than machine language. And this is far closer. This Python language is far closer to something that humans read, as opposed to the zeros and ones that in binary, and the machine language that you can, and the assembly language that you can alternatively code in. She popularized the use of the term bug to mean a error in the program. Debugging is the process of fixing and finding and fixing errors. Okay, so what do we got on this big old green page that matches Grace's Corner, at least in color, if not in theme? We're talking about our programming language. It's going to be Python for this project. And I have a computer screen set up to the side here, and you can see that on this screen. Let's see. Yeah, here we are. On this screen, I have our development environment ready to go, and we're going to talk more about that. But if you've been around computers long enough, you may notice that is a Macintosh, and I think the next few pages will talk about what kind of computer setup that we need. You don't necessarily need my setup in order to proceed here, but I'm limited in terms of the resources available to me and how many screens I can coordinate. So we're going to do this on a Macintosh and inside of a program called PyCharm, but know that program is available for Windows PCs, and we can find something comparable on Chromebooks. So let's talk Python. It's a programming language. It allows people to give directions to computers. That's what a programming language does, and Python is just one of them. What are some things that use Python? Well, yeah, it is. And who uses Python? So what kind of workers, what kind of artists, what kind of teachers use Python? Game designers, data scientists, quality assurance engineers to make sure things are working properly, software engineers, scientific researchers, web developers. So if you have anything from a game to a website that's interactive, you might use Python. What are some of the things that use Python? So not the people, but what are the existing things in the world that were coded in Python? We got the Google search engine uses, and many things at Google. Tools for cancer research, Spotify to listen to music, Reddit, YouTube, Instagram, games like EVE Online and Battlefield 2, and entire NASA projects like software for the Kepler Space Observatory. And just recently we had a successful launch of the James Webb Telescope and deployment, and I wonder how much Python, I wouldn't be surprised to find some Python code enabling that deployment. How does Python work? Now this is really an important thing, because not all programming languages will work in quite this way. If you ever, we talked about binary and how computers know all about zeros and ones, and we have to get our intention, what we mean, what we want them to do, down to that 0 and 1. And so in a way that, given those patterns, the computers can follow our directions. English and other spoken languages are too nonspecific for computers, and binary instructions are too impractical for humans. So we need programming languages to meet in the middle. It's our bridge to talking to computers and having them do what we need them to do. They let us express what we want out of the machines. And so here we have the machine, and that's made up of the hardware. And we could write machine code for those machines. And that's quite difficult, that machine code. It's just about one step up of the actual zeros and ones. And that's very low level. It's very close to the machine's operation. And so here's where Python deviates and falls into one of these two categories of the types of higher level, closer to us, as opposed to closer to the machine, languages that we can use that will then get converted to machine code, then get interpreted by the actual hardware. And one of two types of programs can be converted to machine code. That's type of program that would require a compiler. So we put in our instructions, and out the other side we get a file or set of files that will then be interpreted on the fly to machine code. An interpreter, though, is a piece of software that will not take files that have our code and that then have been compiled and then given to the machine to run as machine code. Instead, the interpreter translates those instructions that we put into our Python file one command at a time. So not as a bundle. We're not going to give a bundle of compiled data to the computer to run. We're going to give it instructions one at a time. And we're going to try to put that in a way we understand so we can get a game out the other end. All right, so a lot of this goes through installing Python, and I don't think I want to spend too much time because we have a computer next to us that already has Python on it. We have an environment, but I would encourage you to go get this book either from the library, your local library, or bookstore, and buy a copy and jump to page 10 and do the little bit of software setup, or reach out to someone to help about the software setup, because we need to be able to interact with a Python interpreter in order to do anything here. I'm wondering, do we need to do any setup in this section? It's telling us, let's skim this really quick. So it's telling us how we're going to interact with the computer in a terminal. I'll show you that in a moment. And it's telling us what kind of devices we can get Python on, how is using the terminal different from all the other things I do on my computer. Well, we're going to be typing in instructions, right? And so terminal will look more like, let's see if I can bring this up. I showed you initially, I said, okay, here is the Python development environment that we might be looking at. And here's a look at what the terminal looks like. Right here, I'm in my project. Typing things. I'm in my project, code this game. And I'm going to type commands here, like the command Python, but I type that out on my keyboard, or copy and paste it in with my mouse. Contrasting with things like that I'd usually use, say, a mouse to click around on. And so this is going to be more of our commands provided in via the keyboard. So let's see. This, I think, is saying, set up a place for your project. So I think we can skip that in the introduction. Again, if you're doing this on your own, this step might require you to, spend more time on that initial setup. We are actually here in the section where we are ready to go with a Python interpreter. And it's good that I have the terminal still up on the screen, because the very first thing that they want you to do to get started, and we haven't heard from Meg for a little while, have we? Well, I'm sure she would like us to get started with a Python interpreter in the terminal. So, if you are on a Mac and you just go into the Applications folder under Utilities, you'll find this terminal that you see on the screen here. And we're going to do some of the exercises that were on page 19. And we're going to use a Python interpreter. And page 19 tells me that I can type that command, Python, and drop right into a Python interpreter. Now, earlier in the book, I kind of breezed past this important point, is that long ago, maybe as many as 10 plus years ago now, we had a Python version 2. And none of our code and no current development is done in Python version 2 anymore. It was what was called deprecated, meaning that it was announced that it was going to be abandoned and all development was going to happen in the Python 3 interpreter. And then it was essentially discontinued. Development of the Python 2 interpreter is no longer happening. So if we see Python 2 anywhere, we're going to have to restart. So we're going to, just for the sake of, slowly developing this, I'm going to close that terminal window and open up a new one. Maybe that's too much screen. And we will type Python 3 to get Python 3. You could see that jumps us right to Python 3. And so you could proceed through the this page 19 with these steps that they're having us do here with the interactivity with Python and its commands, given just typing Python 3. You can see here, if we look a little bit closer, you can see there's actually Python 3.7. 3.9 was what was loading on my computer, just a little bit newer, but not significant to our purposes. You could type some of these commands here and directly into the Python interpreter, and it should do work for you. So let's give that a go. I've already dropped into the Python interpreter on my screen because I typed the word Python 3, and I'm going to try some of the code here on the page. It says that specifically I am in what's called a REPL. And REPL stands for read for R, execute for E, print P and L loop. The REPL reads in Python commands directly and executes or runs them. Then it prints their output, and it just repeats that process into the loop in a loop until we say exit. And it's always fun to try and see what kind of commands work just off the top of our head. Like if we wanted to get out of this REPL, we can see if we type exit, it actually is trying to be a little helpful and saying use exit with parentheses or Control D, i.e. EOF to exit. So if I do exit, oh, look at that. I'm now back in this squiggly location. We had started originally in Code This Game, so why don't we get back there? I'm going to type Python 3 again and hit enter. And now I'm going to do some of the steps here that are outlined in the book. So in the book, I have a note, number 1, type Python 3, type this exact line, print hello world, and then we'll see what happens when we get enter. The REPL reads in your code, it executes this direction, and then it prints out something. And then, of course, it goes back into the loop and waits again to leave the REPL and return to the shell. That's where we were, the terminal. We're going to do exit, and we discovered that on our own. All right, so why don't we give those commands a try? So print hello world, and look at that. It replies to us. It does some work for us. It has provided the words hello world back in reply to our print. Okay, so back to the book. Let's see what's up next. You can tell which program you're in by what's around the area where you're typing. So this is talking about being in my project location. So I called the project Code This Game, and I'm actually in the folder, or what's sometimes called the directory of Code This Game. So this is just more about how to get your project set up. It looks like we have another Grace's Corner. Let's see what this is about. Verify that you have Python installed correctly. Oh, yes, we do. So let's skip that. Play with Python. We've talked a lot about Python. Let's write some code. You can use this section to learn the basics before you jump into creating your game. You will practice the basics of the REPL, which work like this. Input, the interpreter reads what we put in, it evaluates, what's that about, and then it returns some data. So let's make sure it's good at math, and we will type some numbers. Now we might just skip ahead to get to more of the game creation steps. So I'm going to type the number 7, and it knows its numbers. But what about 7 plus 7? Oh, suddenly we can confirm that the REPL, or Python in this sense, is an excellent calculator, at least from this small sample size. Those are all correct. And the book challenges us. This little. I love the drawings in this. For the illustrator, the author got the right illustrator on the job. But here's the little hash mark, that little number sign. Type, and he says, "Your turn. Type at least 5 different addition, subtraction, and multiplication problems. 5 different multiplications. Is that in each category? Let's just do 5. So what if we do 5 plus 7 or 8? There's 13. Good, that's correct. What if we do 10 minus 5, 3? Okay, so we can do negatives. That's good to know. And multiplication. So let's do 64 times 64. 4,096. Let's just try with different spacing. No, that doesn't seem to matter. What about something like that? And what about if we lead with our negative. Okay. So there we go. Very useful calculator. All right. What about division? Oh, what about division? Why did they? That's true. Why did they kind of leave it off? Let's see. You can divide with Python too. Just know, okay? Just know that it will work a little bit differently than you're used to. You can do floor division with 2 backslashes. This will give you just the whole number, and it'll cut off any remainder. Okay. And then you can also do what you think of as true division with a backslash. This is usually okay, but you will run into problems with accuracy. So to keep things simple, try to use floor division with integers whenever possible. Hey, yeah, and look at this. Thanks for the homework help, because it's genuinely a good calculator. All right. But the precision issue is going to be a problem. That'll be a problem if you decide to continue programming in any capacity. If we look over here at our code again, you can see if we do 1/3 that way versus 1/3 that way, that 3 repeating could go on forever with 1/3, but the computer needs to cut it off somewhere. Otherwise, we'll be sitting here for the rest of our lives. So that's what we're talking about when we're talking about the challenge with precision. Okay. Let's go back to the book. Hey, Grace. Grace is down here at the bottom. She says that you may start to get error messages. Here's one that I got when I was doing some math the other day. 1 = 2. And a syntax error, can't assign to literal. All right, so we're going to have to file stdin, line 1. We're going to have to revisit some of these errors and start to pick apart what on earth this means. Because I think, as we get our own code going here, resolving those errors may be the point that keeps us back from advancing. I went back and saw what I had typed, that I had typed an equal sign when I meant a plus sign. In the REPL, you can just try again on the next line. So 1 = 2, but then on the next line, just 1 + 2 = 3. Hey, there's Meg. First, words in Python. We've already discovered that you can have the program print words. Actually, it will print anything that we surround with a single or double quote. And these parentheses, so by sending it to the print, try printing your name. Try printing your favorite song lyrics. Do you want the lyrics to print on 2 lines? Use this new line character. Get a good look at that \n, where you want a line break to appear. So if we are printing here, and we'll use this, get some practice, type at least 5 print statements with different strings. Try writing a poem or listing your favorite foods. So let's go ahead and look at our REPL, and we will just do a print, and I'm just going to list some of my favorite foods: pizza, tacos, I don't know, cereal, toast, eggs. I guess I'm in the mood for breakfast here. And indeed, it typed them out each on a new line because I inserted this new line character between each one. Okay, so let's go back to the book. Here we got your turn. We did our turn, and we have a little power-up section. Power-up section says, when you use strings, and that's the pizza, taco, cereal, toast, and eggs, you can use single quotes. Okay, that's neat. Or double quotes. In Python, both single and double quotes tell the program that you're using a string. Go ahead and pick whichever you prefer. So you can really use your own style here. What if you want to use an apostrophe? Oh boy. So that looks familiar. If you want to use an apostrophe or some sort of character that might be interpreted by the computer as the same thing, right? So our intention here comes down to, how on earth do we convey our meaning? to the computer. And so if we look at our REPL, and we were going to print something that, this is going to be, I don't know, Dad's pizza, right? And then we're going to do tacos. Then we're going to do cereal. Then we're going to do toast. And then we're going to do eggs, just like we did before, but we put in Dad's, right? And we remembered that if they're going to be Dad's, it needs to be possessive with an apostrophe. But we mean to print this with the apostrophe. We do not mean to end our print starting here and ending here, and then passing this on as nonsense, right? So how do we get that in? Let's see what happens. Oh, we got a syntax error, and Python knows right after that other apostrophe or single quote, there's a problem. And so we need to do something about that. And these new lines should give us a clue. Because if we put the \n, the computer has interpreted that to mean, oh, that should be a new line. If we put a \apostrophe, that's what's called escaping the apostrophe, escaping the line. We are escaping out of the computer's interpretation, and we're saying this needs to be quite literal. We don't want you to interpret this as part of the programming language or part of something external to the string. And that string of text is what we're talking about when we're talking about the string. All right, so let's get back to the book a little bit and see what's going on in the next few pages. Here we have, as we move on, another Grace's Corner. You may find that you're getting more error messages now, and we saw a few. Look for some of these common bugs, like a if you can get a good look at this, a missing parenthesis right there, a missing quote, a capitalized print command. Yep, capitalization does matter. Or misspelled, PRNT. Okay, and now we're getting to some of the good stuff here. So, variables. They're all over the place. Variables are used to store information. So this is where we can stash data and then recall it later. And change it for that matter. When we want to use something over and over, or when we want to use data, that will change. So, if you type 12, you get 12 back. But what if you don't want to just give it and get it back? Well, we can store that 12 inside of a variable. And here's the example. An age would be, a good name for a variable if the person I'm talking about is 12 years old, right? And so by using this equal sign, I can put that 12 or assign that 12 and into the variable name. So now if I type age back, I'll get the 12. It's almost like a tag, it says, for organizing and finding information in your program. When you create a tag for data in your program, it's just called assigning a variable. So this equals isn't any sort of test, it's an assignment. It says this does get to be equivalent to this. It always follows the same pattern. And that's true across very many programming languages. I can think of one or two where it's not the equal sign, but very many. Variables variable names point to objects that have a type and a value. So that 12, when we say age equals 12, age is pointing to the value 12, and then implicitly, in case of Python, what kind of type of data that is. Once you put these two things together, this is called an object. And objects have can be described by different features. All right, so a variable can only store one type of data. For example, it cannot store an integer and a string together. So those words, so if we try to put those two things together, we should experiment with that a little bit. So let's take it over back to our REPL. And if we have our age equals 12, and then we ask what age's value is, we'll get back 12. And we know, and you know what, I'm going to introduce this little command. Just like we had the print command, I'm going to do type of age, and it is an integer. Now, I'm going to say name equals dad. And then I'm going to say name. And lo and behold, I get back dad. Now, what if I say type dad, or type name, sorry, I get a class, or the data type of string. Now, the book just had us, just gave us a little bit of info that a variable can only store one type of data, and I like the illustration that they have for this because what are my cats? I'm just thinking of the cats and dogs crammed in to that. A little box, I guess, a little box. But I'm curious if we can only have one type of data, what happens if we do age name equals, and then we do age plus name? So we can't add those things together. Let's say, I'll say my age equals 44, right? And what if I try to do combined ages equals age plus my age? That it liked. So now I can do combined ages, and I get 56. Holy cow. Wowee. So we found out something here. The value can be changed, and it needs to be of the same type if you're going to combine them. All right, so that might be all that we do for this video today. We're coming up on 30 minutes, and we're already up to page 26. So I am going to end with one of my favorite foods. Oh, look at that, a little taco. He's a little taco character. I love the illustrations throughout this book, and I think why don't we use this bit of code up here, because it talks about tacos, to end our walk through this book. So down here it says, what about the value of best food equals string.upper? All right, let's see what happens. So we'll take our REPL, and we'll throw some more things into it. We will say that our string equals tacos. So now we've got a variable that is named string, and inside of it we have the value of tacos, and we know I've introduced this little type, and we know it's a type of string. So what if we say the best food equals string? Remember that string is tacos dot upper with parentheses. Now let's find out what's inside of best food. What value? Whoa, totally uppercase. So we've got a string that we can perform operations on. We can perform these kind of methods that allow us to change them. I wonder if it changed string. No. So string is still lowercase tacos. Best food is uppercase, because we took the string and it looks like it put the value of string after it's passed through this upper into the value of best food, which remains a string in terms of a type. Well, I think that's going to be it for today with this book. We should put a bookmark in this book. If I can get it off the table. It's kind of heavy. If you do wind up going to the bookstore or the library to get yourself a copy, I will say that while I've had it laying flat on the desk, what I would do in your own use is note that you can fold the back of the book. I don't know if I have enough space here to demonstrate, but you can fold it out like this, and it becomes a stand, so that as you're working through the book, you can rest this on a surface and have your computer environment right next door. So we'll end today on and for this video on page 26. And as I look around, I do not see any bookmarks. So when you don't have a bookmark, you just use another book. There we go. So that's it for today, and see you next time.
Dad, don't go upstairs. I'm down here.
What up, Noah?
Don't go upstairs. I'm down